If I told you a computer could get good at something without me programming every step, would you believe me? That's the promise of machine learning. It's not magic, it's pattern finding. Here's the hook. Every day, photos get spam filtered, unlock your phone with your face, your maps guess where you're going. None of that works well with classic if this, then that code. So instead of handwriting rules, I feed a computer examples and let it learn the rules itself. Think of it like this analogy. Machine learning is training a friend to recognize your favorite coffee order. The first time they guess. Maybe they bring a latte. You say, close, but oat milk, not dairy, and no syrup. They adjust. Next time, they're better. Over time, after enough mornings and your tiny corrections, they get it right almost every time. That's supervised learning, examples plus feedback. There's more. Sometimes there's no teacher, just patterns to discover. Imagine dumping 1,000 photos into piles based on what looks similar. Dogs with dogs, sunsets with sunsets, without labels. That's unsupervised learning. And then there's reinforcement learning. Teaching a dog tricks with treats. Try a move, get a reward or not, and repeat until it nails the trick. Under the hood, it's math that shrinks errors. You start with a model, a function with knobs called parameters. You show it examples, inputs, and the answers you want. It makes a guess. You measure how wrong it is, and you nudge the knobs to be less wrong next time. Do that 1,000,000 times, and you've got a trained model. Let me walk through a clean example. Building a spam detector for email. Step 1. Collect data. Thousands of emails labeled spam or not spam. Step 2. Turn emails into numbers the model understands. Count how often words show up. Look at sender patterns, links, weird formatting. Step 3. Pick a model. Could be a logistic regression for simplicity, or a small neural network. Step 4. Train it. Feed in a batch, compute the error, adjust the parameters, repeat. Step 5. Test on new emails it's never seen. If it overfits, memorizes your training emails, it'll fail in the wild. So you hold out a validation set, tune complexity, maybe add regularization so it generalizes. You also watch metrics beyond accuracy, precision, and recall. Precision asks, when I say spam, how often am I right? Recall asks, of all the spam out there, how much did I catch? Balance those based on your tolerance for missed spam versus false alarms. Scale the idea up and you get image recognition. Instead of counting words, you feed pixel grids into a convolutional neural network that learns edges, textures, then shapes. Or recommendations. Models learn what you like from your watch history, compare you to similar users, and predict the next video you'll click. Here's the twist. Models are only as good as the data. Biased data, biased predictions. Messy data, messy outputs. So you clean, balance, and monitor. And no, machine learning isn't a brain. It doesn't understand like humans. It's an efficient pattern machine that gets scary good when the data is rich and the objective is clear. So the recipe is simple. Define the problem, gather quality examples, pick a model, train, validate, deploy, and keep an eye on it. Teach the system like you teach that friend your coffee order. Clear feedback, lots of reps, and corrections when it drifts. That's machine learning in plain English. Learn patterns from data to make predictions without hard coding every rule. And once you see it, you start spotting it everywhere.